Welcome back from the ad break, and let's continue with our lesson. So we are going to go into that first concept on our concept map, and that is to add and subtract like terms. So like terms can be added or subtracted. Unlike terms cannot be added or subtracted. So we have to keep that in mind. Let's look at some examples. So here we have a 5x cubed plus a 4x cubed. Now, are these two like terms? Yes, they are, which means that we can add them. So 5x cubed plus 4x cubed, that is going to give us a 9x cubed. Now remember, we are not multiplying here. We are not multiplying, so we will not add those exponents. We are adding. So before we can add or subtract, we just make sure that they are like terms. And if they are like terms, they can be added or subtracted. But if they are not like terms, they cannot be added or subtracted. Let's move on to the next one. We have the 17y squared minus 7y squared. Now, are they like terms? Yes, they are like terms because they have the same variable and the same exponent to that variable. So if we say here 17y squared minus 7y squared, yes, that is going to give us a 10y squared. That is absolutely correct if you also got a 10. What about this next one here? Can you identify the like terms? Remember, like terms can be added, unlike terms cannot be added. So which ones are like terms here? Yes, that 9p exponent 4 and the negative 6p exponent 4. So we can subtract those two there. So we are going to say there the 9p exponent 4 minus the 6p exponent 4. So 9 minus 6, that is going to give us a 3. And of course, we still have that p exponent of 4. Then what about that minus 3q squared? Well, because it does not have anything that is the same or it does not have a like term with it, so we are just going to write it as it is, and that is going to be minus 3q squared. Now, can we subtract those two together? No, we cannot. And the reason is that they are not like terms. Let's look at this last one here, and we are going to say there 15m plus 7k minus 8m minus 30. Now, are they like terms? Yes, they are like terms here. We have a 15m and a minus 8m. So we are going to now subtract those two. So 15 minus 8, of course, we know that is going to give us a 7m. And are they more like terms? Yes, we do. We have that 7k and that minus 30k. So 7 minus 30, do we know what answer we get from that? Yes, that is going to give us a negative 23k. So our answer is going to be a 7m minus that 23k. So those were the like and unlike terms, or adding the like terms and the unlike terms. Let's move on to the next concept in our concept map, and that is the multiplication of polynomials. So let's see how we are going to work with that. So multiplication of monomials and integers with monomials. So let's start with that. When we multiply a monomial with a constant monomial, which are integers, we multiply the integers and keep the variables as they are. Let's look at an example. Let's simplify the following expressions. So the first one there is a 3 multiplied by a 2x. Now, as we can see, the 3 there has no variable. That is our constant. That is our constant monomial. So how are we going to multiply these two? Well, we are just going to multiply the integers, which is going to be 3 multiplied by 2. That is going to give us a 6. And of course, because there's no other variable to multiply with that x, we are going to keep that variable as it is. Let's look at the next question. This one says there a negative 7p cubed multiplied by our 9. So how are we going to work with that? Well, we are going to just say the negative 7 multiplied by the 9. Now, what is negative 7 multiplied by 9? Yes, it is negative 63. Remember, when we multiply a negative number with a positive number, the result is a negative number. So we are going to multiply. We have multiplied negative 7 and 9, and we are going to write the variable as it is because that variable has no other variable to multiply with. Now, let's continue with multiplying those monomials and integers with monomials. But now we are going to look at a non-constant monomial. So when we multiply a monomial with a non-constant monomial, we multiply the integers together and then we multiply the variables together. And let's not forget to apply those exponent laws. Now, a non-constant monomial, remember, it is just an integer that has a variable as well. So let's remind ourselves of those exponent laws again. Remember your exponent laws. If we multiply powers of the same base, we are going to add those exponents. Let's look at that. So let's simplify this expression. We have the 4a cubed multiplied by a negative 12 x exponent 5, and we are missing there a bracket, but let's multiply those two numbers. So firstly, we need to multiply the integers together. So 4 multiplied by a negative 12, do you know what that answer is? Yes, it is a negative 48. And then we are going to also multiply our exponents, our variables together. So there we have the a cubed with the x exponent 5. Now we need to remember our exponent laws here. Remember, exponent law says if the base is the same, then we are going to add the exponents. Now, is the base the same here? No, it is not. So that is our final answer. Let's look at the next one. So here we are multiplying 8h squared multiplied by 10h cubed. So we are going to say the 8 multiplied by the 10, that is 80. And then we have our h squared, and that is multiplying with our h cubed. Now, because this is the same variable, remember, same base, we are going to add the exponents. So 3 plus 2, that is going to give us a final answer of an exponent 5. So our final answer is 80h exponent 5. Let's look at now multiplying monomials and integers with binomials. So firstly, we're going to start with that constant monomial, which is the integers. Again, we are going to just multiply each term of the binomial. That is very important. Each term of the binomial has to multiply with that constant monomial. And then we're going to keep the variables as they are. Let's look at this first example. So here we are given a negative 6 multiplied by the binomial in the bracket there, which is 3x minus 5. So how are we going to multiply this binomial? Now remember, this is a binomial because it has two terms, and we need to make sure that each of the terms in the binomial multiplies with that negative 6. So we are first going to multiply the first term of the binomial, which is the 3x. So that is the negative 6 multiplied by the 3. Our answer there is going to be a negative 18, because negative 6 multiplied by 3 is 18, is negative 18. And because there is no other variable there, then we are just going to keep that variable as it is. Now remember, in the binomial, these terms are being subtracted. So we are going to subtract that there. Then we have a negative 6 multiplying with the 5. Now negative 6 multiplied by 5 is indeed a negative 13. Now we have an answer of a negative 18x minus a negative 30. Remember, subtracting a negative number is the same as adding its additive inverse. So that is going to be a negative 18x plus 30, and that is going to be our final answer there. Let's look at this second example. So now we have a 9 multiplied by the binomial, which is 3p plus 2. So we are going to now say the 9 multiplied by 3, that is going to give us a 27. So 9 multiplied by 3 is 27. And of course, we have that variable of p, and we are going to write it as it is. Then we are adding in this binomial. So we are going to further multiply the 9 with the 2, because remember, each term in the binomial must multiply with the integer that is being multiplied, or the monomial that is being multiplied. So 9 multiplied by 2, that is going to give us an 18. So our final answer there is 27p plus 18. Let's quickly go to an ad break, and then we'll see you just now for the rest of our lesson.